This tutorial will cover octagonal and square vertical vessel foundations using the Plant Mode and STAAD Foundation Advanced. On the opening screen, click Plant Mode and then Create Vertical Vessel Foundation on the main navigator under Project Info. A wizard will pop up with a sequence of steps to create the vertical vessel design. The user can skip to any step using the navigator on the left, or go through each one in order. The first step, called Vertical Vessel Job, only specifies basic information like the title, unit system, and design code. Please note that Vessel Job ID for a file should be unique. This is critical to create multiple vertical vessel jobs in the same file. In the Geometry tab, you must first specify the unit which will be used for all parameters in this section. The default option is feet. Then choose the foundation type, either octagonal or square, and foundation support type, which is either soil or pile cap. I will first select octagonal and then later go back to take a closer look at the square foundation option. A separate video will explain the pile cap foundation option for vertical vessel footing. Next, fill in the parameters under Vessel Geometry, Pedestal Geometry, Elevation, Footing Geometry, and Overburden and Buoyancy. Footing geometry contains minimum and maximum options for the footing diameter and footing height to allow for design calculations. All of the parameters are labeled and shown in the diagram to the left. Bottom of foundation will be used for the detailed drawing only to show the elevations of different levels. Anchor geometry also gives user input for the unit type. In this case, the default is inches. This section contains all of the anchor bolt arrangements and size specifications. Three main types of loads are used to design vertical vessel foundations. They are a vertical load, base moment, and base shear. The locations and default orientations of these loads are shown in the diagram. You must specify the unit type for each one of these loads. 4 types of standard loads are given for each of the 3 load types. The first, empty load, is as specified in the PIP Vertical Vessel Foundation Design Guide, the empty dead load of the vessel, including all attachments, trays, internals, insulation, fireproofing, agitators, piping, ladders, platforms, etc. Operating loads are the empty dead load of the vessel plus the maximum weight of the contents, including packing and catalyst during normal operation. Test loads are the empty dead load of the vessel plus the weight of the test medium contained in the system. The test medium should be as specified in the contract documents or as specified by the owner. Unless otherwise specified, a minimum specific gravity of 1.0 should be used for the test medium. Erection loads are loads encountered while erecting or constructing the vessel. Remember to reference the diagram when entering positive or negative values. Entering a positive value for vertical force causes an upward force. The self-weight factor may be altered. The user-defined load table is for any additional types of loads which are not covered by basic load cases. In some cases they might be needed. In wind load generation, the user has an option between user-defined wind load and calculated wind load. The calculated wind load option will calculate the shear and moment value based on the given input values. A few of the values are taken from tables in ASCE 705, which are shown if you click on the buttons. Tables 6.6, 6.1, and 6.21 are provided to determine KD, I, and CF. A description of each of the input values is given in the blue box. If the shear value and moment value are already known, then selecting user-defined wind load will allow for their direct input. A partial wind case percentage is optional. Time period calculation has 3 input options. They are direct input, mass table, and program calculated. Direct input allows the user to manually input the fundamental period. Mass table calculates this value based on the inputted values in the distributed mass table. Program calculated calculates the fundamental period using a program calculated mass table. Long period transition period must be inputted for each description. With seismic load generation, the user can choose between direct input seismic loads, mass table CG, and user-defined CG. With direct input seismic loads, the user must input shear and moment values for operating seismic load and empty seismic load. Units for shear and moment must be specified as well. The mass table option may only be used if the same option was selected in the time period section. User-defined CG allows the user to either select using zip code or enter values manually. A response modification factor, R, or importance factor, I, can be edited. A load combination table is shown similar to the load combination table in general mode under loads and factors. Here, the user can choose to either use ASCE 705, PIP, or enter his or her own load combination values. If either ASCE 705 or PIP is selected, values in the table can still be edited. Design parameters contains basic information under the three main sections: material density, bearing and stability, and concrete design parameters. After all of the steps have been completed, click Finish. This example says Edit because I switched to an existing example file to show standard values. The vertical vessel can now be viewed in the geometry view. This is a graphical representation of the user's input with a typical vertical vessel. From this point, you can either edit, which takes you back to the vertical vessel creation wizard to edit any selection, delete, or design. I will go to Edit to more closely examine the square foundation option. Selecting square foundation changes the diameter DF input into a length LF input to specify the footing dimensions and footing geometry. You can also notice a slight change in the diagram, which changes the footing from octagonal to square. This is the only change. All other steps remain the same as octagonal footing. Designing creates a calculation sheet and detailed drawing. Calculation sheet specifies how each footing was designed. It includes detailed steps, figures, and references to the code which was used for design. Let's take a closer look at the concrete crushing check shown in the calculation sheet. Here you can see the procedure STAAD Foundation Advanced uses according to PIP STC 03350 section 4.6.2 to calculate the compressive force in each dowel, which is used to calculate the compressive stress in the concrete. This design passes because this value is less than the compressive strength of concrete. This section checks trial depth against punching shear strength. It strictly follows ACI standard and displays each equation number for reference. Detailed drawing gives plan and elevation views for individual footings. This drawing shows support and footing dimensions and any reinforcement. If there are pedestals or anchor bolts, their drawings are also shown. Thank you for watching this tutorial.